Hello, everyone, and welcome to webinar 004. Today, I'll be talking about building your IoT security system. I'll be exploring how to use the Raspberry Pi PicoW, Python, and the Adafruit IO platform. All right, once again, I'd like to introduce myself. So my name is Dr. Olakune Elijah, and I'm a researcher, author, lecturer, and a founder. If you're interested to see some of my details, you can check my Google Scholar profile and so basically, I'll be focusing on the cycle design. So this webinar is going to be a build up on the previous webinars we've had, where we looked at how to design a complete security system using the Raspberry Pi PicoW. So we'll be building up on that. So I'll talk about the cycle design aspect. Then we'll move next to the firmware development. So how we use the Scikit Python to write the codes that controls our microcontroller for us to be able to connect our IoT device, our security device to the IoT platform. Then next is I'll talk about how to establish or set up the IoT connection using the Adafruit IO platform. So basically, this is the system architecture for the IoT security system. So basically, you have your um, Raspberry Pi PicoW microcontroller connected to some sensors, which I'll talk about later. Then from the Raspberry Pi PicoW, your connection is established using your access point. So your access points could be your Wi-Fi router in your home, or it could be your mobile phone or any Wi-Fi device that you have around. So once the connection is established between the Raspberry Pi Pico and the Wi-Fi, then with that, it's able to access the Adafruit IoT platform via what you call your base station. So it could be via 4G, 3G, or 5G network. All right. Now you notice you have the MQTT here in this part. So there's the IoT data communication protocols. We have different types. So you could either use the MQTT or the HTTP. In this case, the MQTT stands for Message Queuing Telemetry Transport. It is a lightweight messaging protocol that is designed for small sensors and mobile devices, and it is optimized for low bandwidth, high latency, or unreliable networks. Okay, so the MQTT is very good when you are deploying IoT devices. Then you also have the HTTP, which stands for the Hypertext Transfer Protocol. It is the foundation of data communication on the World Wide Web. Okay, so it's basically used by browsers and servers to request and deliver web pages, files, and data. So the HTTP is basically the what's used for our internet browsing and everything. So you can also use it for IoT device, but in this case, it's not a lightweight, it's heavyweight. That is, the packet size are quite heavy. So it's going to lead to consumption of your data very fast compared to when you use the MQTT. All right. So you can use any of them, but the MQTT would be preferable for things like IoT devices. So it can be used for your IoT security system. Then we have the Adafruit IO platform. So basically what this does is it registers all IoT devices. It manages all IoT devices that's connected to the platform, where the data is coming from, and it aggregates all the data coming from your IoT device. And from there, you can do, you can download your data, you can design your dashboard to visualize your data and things like that. In some cases, you can also have some analysis carried out if you have some application servers also working on the IoT platform. So for this Adafruit IO platform, it has some basic functionalities, especially if you're just a free user. Okay. Then from there, You can use your mobile device to visualize your data, to monitor what is happening, and also to set some commands. Maybe you want to switch up some things. You can send commands to your Adafruit IO platform. Then this sends the commands to your IoT device, either to switch off or to trigger. And of course, you can monitor all your data, what's happening. Okay, so this is the simple architecture regarding your IoT security system design. Next is a block diagram. So this is the IoT device. So like I said, you have your microcontroller, then you have sensors. So you could have your RTC module that measures your keep records of your timestamps. Your SD card that logs in data as backup. Your power supply that powers the whole device. Then you have things like window sensors, those sensors, alarm system, motion detector, and of course an OLED display that displays some of the informations to you on the device. And this is the circuit diagram. Okay, so this is basically the connections, the SD card, the OLED, the RTC module, those sensors, and all of that. So for this particular webinar, I will just focus on demonstrating how you can connect your magnetic dot sensor. This is how it looks like. Okay, so one of the branches is connected to a fixed part of your door, while the other one is mobile. Each time it comes in contact, then it establishes a connection. And with that, you can either tell whether the door is closed or the door is open. All right. Then we have an active buzzer here. So once we can configure the system, if the door is closed and there's a motion detected, you should sound the alarm. So however you want to configure a system, it could be time-based. Once it's past 7 p.m., 8 p.m., you want the alarm to go off, then you can program your microcontroller to do that. So we're looking at the magnetic dot sensor, active buzzer, and PIR motion sensor. Then this is the pin mapping. So I talked about pin mapping in our previous webinar. So maybe you can go through the last on our YouTube channel, that up there, and I can also provide a link to this. So basically, your pin mapping tells you which pin of your microcontroller is connected to the various components for the security system. So in this case, our PIR motion sensor is connected to GP19. The dot sensor is connected to GP28, and the buzzer is connected to, the dot sensor is connected to GP27 and buzzer to GP28. So this is the demo. So the prototype, all right, which I'll be demonstrating today. So I already have my Raspberry Pi Pico W on board, the PIR motion sensor, which is connected, the dot sensor, magnetic dot sensor, and the active buzzer, all right? Now, let's come to part 2, which is the firmware. So firmware basically is the code you write into your microcontroller to perform whatever tasks you want to perform. So in this case, we're using CircuitPython. Remember, there are different ways you could program your Raspberry Pi Pico W. You could either use the MicroPython firmware, or you could use the CircuitPython, all right? Or you could use C++, okay? So in this case, we're using CircuitPython, and for you to use the CircuitPython, first you need to install the CircuitPython into your Raspberry Pi Pico W, all right? And to do that, you just go to this link. Okay, so this is the link I have here. So we have various versions. So I think the latest stable version is the CircuitPython 9.27. So you need to download the UF2 file, and you drag and install into your, there's a process for that. So you just go through the process. They will guide you on how to install that. I think I've done that in my previous videos, so you can go and check. Then the next thing is you need to note, okay, like I said, there are various versions. You could either use the 9.27, which is the latest stable, or you could use the CircuitPython. So this is the alpha. So this is still under test, all right? That's why it's called an alpha. So, but I should recommend you use the CircuitPython 9.27 for installation. So I've already installed this on my Pico W. Okay, next, after installing your CircuitPython, make sure it's installed on your Pico W. Then the next thing is you need to get what they call the CircuitPython bundle. So the CircuitPython bundle consists of all the libraries you will need for different components you'll be interfacing with on your Raspberry Pi code review. So you go to this link again. Let's go to the link. All right, so this is where you can download. So again, you have to select the correct bundle for your CircuitPython version. If you're using version 9.x, you select this CircuitPython bundle 9.x. If you're using the version 10, then you select this. All right. So once you click on this, a zip file will be downloaded onto your system. You need to unzip the file. Once you unzip the file, you get something like this. Okay, so once you unzip the file, you get something like this. Okay, then you open the zip file, you see a folder called live. So this folder has all the different libraries that you need for working with different components on your Raspberry Pi PicoW. So you only need to know which library is needed, then you copy it and install it into your CircuitPython directory. So just a second, I'm going to open my Scikit, my Tony IDE. So, okay. So this is the folder for my Tony IDE. So once you connect your Tony IDE to your system, your Raspberry Pi PicoW to your system using a USB cord, it will automatically open a drive for you that consists of your files on your circuit, your PicoW. All right. So in this case, you can see there's a folder called live here. Okay. So this is where I copy any library I need. I'll copy from the bundle and I'll save it into my live in my circuit Python. Okay. So let's look at some of the libraries we need. So in this case, for this particular project, for us to be able to connect our Raspberry Pi Pico to the Adafruit IO platform, we need the following libraries: the Adafruit mini MQTT folder, Adafruit_IO, Adafruit connection manager is a folder, Adafruit_request a folder, and on the Adafruit. So all these folders, I will need them. So in this case, you just need to go to your live file. Let's say, for example, the Adafruit mini MQTT. Let's look for it. So this is it here. So if you look at my CircuitPython, right, folder. So if I open this, you can see it's already there. So I just need to copy from here and paste into this place. And that's all. So every other folder that I need, I'll just need to copy and paste here, right? So you can see my Adafruit request is already there. And my Adafruit connection manager is already there, okay? So Adafruit IO is already there. So once all these libraries are there, then I'll be able to run my codes on my PicoW. So let's move a bit further. So now this is the code, right? So the codes are divided into different segments. So these are the libraries we need to import into our codes. So I can install them into your save them into your live folder in your CircuitPython. You need to now import them into your code. So you say import time, import board, import all of this. So these are the libraries we need to import. You can see from Adafruit mini mqtt.adafruit as mqtt, all right? So after that, then you need to provide your configuration for your Wi-Fi. So if you are using your phone as your access point, you need to provide the SSID. So in this case, this is then my password. Then of course, you need to provide the username on your Adafruit IO. I'll talk about that in a minute. And of course, the key on your Adafruit IO platform. So once you have created an account with them, they'll provide this for you. So you need to copy them and paste them. Then this is for the feed. So we're going to create two feeds that will be sent to our Adafruit IO platform. One is motion and the other one is doc. Okay. So this is aspect talks about the Wi-Fi connection. As you can see, print connecting to Wi-Fi. So if it tries to connect, it will tell you it's connecting. Once it's connected, it will tell you connected to Wi-Fi. Then after that, it will try to connect to your Adafruit IO platform. Then next is this part talks about the pin configuration. So again, you notice on our pin mapping, GP19 is used for the PIR, GP27 is used for the dot sensor, and GP28 is used for the buzzer. So all of this has to be defined in your code. Then the MQTT setup and connection. So this is the function that helps us to set up our MQTT for connection from the PicoW to the IoT, the Adafruit IO platform. Okay. So all of these are functions that helps you to manage the communication, sending of data, and receiving of data. Then this is the main loop for the code, okay? So this tells you why the system is on, keep doing this. So it's going to be searching, monitoring the PRF sensor, check the values of the dot sensor as well. So if anything is detected, it will send, if there's a change in the status of the dot sensor or the motion sensor, it will send the data to the Adafruit IO platform. And in any case, it's going to sound the alarm if uh, the door is closed in this case and there's a motion detected. So now the third part, which is the last part. So this talks about the creation of accounts. Okay, so the Adafruit IO. So there are different steps you need to go through to use the Adafruit IO. First, you need to create an account with them. All right. Then once you create an account, you create a device, you create your feed, you create your dashboard, and you download your data. All right. So I'm going to be demonstrating this to you to help you understand. So let's go back to, let me bring my Tony IDE up. So this is Tony IDE, the software you use to write your Scikit Python and also to program your Raspberry Pi PicoW. So again, I've talked about using this in our previous webinars. So the first thing is for me to connect. Let's connect. Okay, so once you see these three dashed lines, it tells you um, it tells you your PicoW is connected to your Tony IDE. Once you see this prompt, okay. Now I'm going to open the code, which is IoT webinar. Okay. So this is the code I showed you earlier on. So these the libraries we're importing. Remember, I told you the dependency libraries are all saved in your light folder here. So you take all the required folders, you save them here first before you can use them in your code. All right. So this is my access point password, then my username for my Adafruit and my password there. Okay. Then you have your motion. These are the feeds I've created. Okay. So connecting to Wi-Fi. So the codes are all there. So I'm just going to run it now and let's see what happens. So if I run, you notice here it's saying connecting to Wi-Fi. So let's see how long it takes to connect to Wi-Fi. Okay, connected to Wi-Fi, connecting to Adafruit IO MQTT, connected to Adafruit IO. Okay, so monitoring motion and door sensors. Okay, so currently the motion is false and the door is true. That is, the door is closed. All right. So door value is 1 and uh, um, the the motion is false. So these are data that has been sent. Okay. Now, like I said, each time I move, if the motion is detected, it will sound an alarm. Okay. So now let's go to the IoT, the Adafruit IoT platform. So to go to the Adafruit IoT platform, you just need to type in Adafruit IoT, then to take you to their web page. Okay, so this is the web page. So you need to sign in, create an account. So I sign up, create an account. So I've signed up. Okay. So first, like I said, you need to add devices. So you can see my Raspberry Pi PicoW is has been created. So this is the device I created. Let's say you want to create a new device. You can just click on this button. So there are different microcontrollers that you can connect to their platform currently. So you need to come and choose. So in this case, we're using the PicoW. If you have the Pico2W, you can also select that and that will be fine for you. All right. So I haven't done that. So if you select, let's say, for example, the device, then you need to go through all these steps. Okay. Note that you don't have to go through all the steps. Now, if you are going to be designing based on, you want to develop your application based on graphical user interface, you don't want to write your codes in your Scikit Python, then you can download this wiper snap. Otherwise, you can skip it, because in this case, we are writing our codes directly on this. If you don't want to go through this process, you don't want to write codes to connect to the other Fruit IO, then you can decide to go with the option of using their own firmware installed on your PicoW. And what you just need to do is drag and drop different components. It will generate the codes for you and to work as well. But for this case, we're going to skip. You don't need to. If you're using your Scikit Python, you just need to skip some of these steps. And once you do that, then I think that will be fine. Okay. So if you have created your device, then you go back to your feeds. Okay. So feeds, you can see we're sending, we created two feeds in our Scikit Python code, which is door and motion. So you can see it's sending the data anytime it observes changes, and it's recording the time it receives the change in data. So if I see now my door is closed, if I open it, which is going to be 0, and I refresh my feed, okay, so you can see it's already there. So once you've established connection with your, you've established connection with your, from your PicoW to your Adafruit IO platform, and you're able to see your data streaming in, then the next thing is to create a dashboard. So this is the dashboard. So you can click on dashboard, click new dashboard. So in this case, I've created IoT security dashboard. So just to demonstrate some of the things we've done. So in this case, I've created some items on my dashboard. Okay, so they are called blocks. So normally when you create a new dashboard, it's going to be empty, blank. Then you'll be allowed to add different blocks. To add blocks, you just come here and create new blocks. So there are different blocks that can be added. You can have toggle, reset, slider, your gauge, line graph, streaming. You want to streaming data, okay? Text display. And so these are the components that are available for free users. So if you are a subscribed user where you pay some amount of money, then you would probably be able to use more of the blocks for your dashboard design. Okay, so for free users, we are limited. So basically, I think you can support maybe two or just limited number of devices, and every device has limited number of dashboard you can create on, and also limited number of feeds that you can connect, you can create. Okay, so we have door monitoring. So you can see I use the block indicator to indicate if the door is open or closed. So let's see now the door status is red because it's the door status is red, okay, because it's open. So if I close it back, it's going to be green. Okay, then once my motion is detected, it's going to be red. So now it's green because no motion is detected. So if I move my hand, you can see it's detected motion and it will change to red. Okay. Now this is a line graph which I use for the door status. So it's going to be monitoring how the door is opening and closing. So for once it's closed, it goes to 1. Once it's open, it goes to a 0. All right. So let me open the door again and see. Changes to, you can see the door is open, and of course, if I move my hand for the motion sensor, there's no alarm because the door is open. Once I close the door, now I move my hand for the motion sensor, the alarm comes on, and also the indicator changes to red. So this is working. So if you want to add more blocks, there are a lot of things you can do. You can edit layout. Let's say you want to move your positions of your dashboard, blocks in the dashboard. So let's say I want to move this a bit this way. I want to bring this here. I want to bring this here. Okay. There are a lot of things I can add. I can add a text box to say when the door is open, door is closed. I can add a string to provide real time all the data, the changes, the door was open at so time, and all of that. So there are a lot of things you could do. Then if you want to edit any of these, you can edit as well, edit block. So if you want to edit any of the blocks, so you need to select what field you want to provide for that block. So in this case, it's this door. Click on next. Then you can change, you can edit the title. You can also you can change the color. If you want the door, once it's closed, to be red, you can come in and change these colors. Then the conditions as well. So if the value is equal to 1, that's when you want it to be green. Otherwise, it's going to be red. All right. Then once you are done with your changes, you can say update block. So look at this example, other example, the block. So in this case is the motion. All right. So I click the next step. So if you see, I say it's equal to false. So each time it sends a text data false, all right, it's going to make sure the indicator is red. That is motion has been no motion is detected. All right. So you can define how you want it to be to be shown. If it's false or true, what color should show. Then you say update block. All right. So yeah, so that's how you work on your. So once you've made all your changes, then you can say save layout, and it remains like that. Right. So let's test again. I'll open the door. Once I open the door, you can see. Then once motion is detected, it changes to red. So let me move my hand. Okay, you can see motion was detected and all of that. Then of course the values are changing with respect to time. Okay, so one more thing I'll show you, you can also download your data. So you go back to fields. Let's say you're interested in downloading your data for analysis. So you can check, select any of the fields you want to access the data. So this is the data, right? So you can click on download all data. So again, for free users, there are some limitations. Maybe they are allowed to download only once in 10 minutes or something like that. So please take note of that. All right. So let's go back to our slide. Okay, so I've talked about creating an account, how to create a device, create feed, create a dashboard, and of course, download your data. So in summary, we've looked at how we can design and build our IoT security system using the Raspberry Pi PicoW, the Tony IDE for the firmware, and of course, using a cyclic Python. And for the IO part, we've looked at using the MQTT and also the Adafruit IO for our IoT platform. So for those of you who probably you are interested to start building your own device, so you can reach out. We have different components. So we have the PicoW with header. So these are the ones with pins, header pins. We have the PicoW without header pins. In that case, you're going to be buying your own pins, you do your soldering, and you use it. So if you know how to solder, this may be a cheaper option for you. Pico 2W, so with header pins. So these prices are quite good. If you check around, they are quite expensive, but we are giving a very discounted prices to encourage people to become makers and innovators. All right. So if you don't want to go through the process of you connecting your cable either through your breadboard or your variable, then you can just buy these development kits where you can easily set up your device very fast. So all you need to do is buy this and get the end of the Pico W's, insert it into the slot, then get your connecting cable to your sensor, and under few minutes, you're already done with your connection rather than soldering and all of that. So this is quite good. Then we have this other one. This has the Pico. Pico does not have W. So this one can, if you want to do IoT projects, then you need to get your ESP01 Wi-Fi module, where you insert it here. Then, of course, you'll be able to convert these to an IoT platform. All right. So if you want to order, you can look at contact the WhatsApp number 081 363994461. And if you want more projects, components, and all of that, you can also visit the WhatsApp link where you see a lot of catalogs, and you can get your copy. Thank you for watching this webinar. So if you have enjoyed this webinar, I'd like you to like it, share it, and also subscribe if you haven't subscribed. Then also invite others to watch. So I'll see you in our next webinar where we'll be looking at more practical projects. Thank you and bye.